Imagine standing over a manure lagoon in midsummer, nose wrinkling and wondering, can something so smelly help fight climate change? Well, it turns out that how we treat manure before it hits the field can make a big difference. In Europe, farmers are acidifying manure during storage, not to tame its smell, but to help reduce ammonia and methane emissions. Here in the US, that practice isn't common yet, and we don't quite know what happens when acidified manure is applied to soil. Previous studies have shown that it does reduce ammonia emissions compared to conventional manure, but we still don't know how it affects emissions of nitrous oxide, a potent greenhouse gas, or how much nitrogen remains available to plants. We also have another tool to help curb manure emissions, nitrification inhibitors. NIs are chemical additives that slow down the conversion of nitrogen between plant available forms. They're known to reduce manure storage nitrous oxide emissions and help crops use nitrogen more efficiently. The big question is, what happens when these treated manures hit our soils here in Wisconsin? So we asked, what happens to nitrous oxide emissions and nitrogen availability when Wisconsin soils are amended with acidified or NI-treated manure? We expected acidified manure to reduce those harmful emissions, but maybe at the cost of also reducing the nitrogen that's available to plants. And we expected NI-treated manure to reduce emissions of nitrous oxide and boost nitrogen availability. Here's what we found. In the sandy soil from Hancock Research Station, the acidified manure increased nitrous oxide emissions compared to conventional manure. But in the silt-loam soils from Arlington, there wasn't much difference. In the NI-treated manure did what we predicted in half of the soils. It reduced nitrous oxide emissions in both the sandy soil and the ringwood silt-loam, while having no difference in the plainwood silt-loams. Surprisingly, there was no significant difference in the plant available nitrogen between either treatment or the conventional manure after 28 days. So what does this mean? The benefits of manure treatments may depend on soil texture. A strategy that reduces emissions in one soil may have little effect or even unintended consequences in another. As we work toward climate-smart agriculture, understanding these trade-offs is critical, because even the humble manure lagoon has a role to play in solving big environmental challenges. Thank you.
Thank you, Mitch.